Imagine a planet where noon is set not by its star, but by a lighthouse at the heart of the galaxy. The active nucleus wakes, the accretion disk brightens, and a hard, blue day spills across interstellar space. UV lines stitched with soft X-rays that a local sky can feel. Photons between and EV punch into the upper atmosphere, kicking electrons out of N and O, igniting ion chemistry that doesn't care about weather or seasons. In minutes, O cascades, NO and NO bloom from N and O pathways, Hawk cycles accelerate as HO is photolysed, and the familiar ozone triad OOM meets its nemesis in catalytic NOx and Hawk's loops that shred column ozone far faster than a quiet stellar UV field ever could. Above the mesopause, secondary electrons seed a forest of reactions. Below, radiative transfer carves spectral windows where specific lines lie. HNO₃ drives selective dissociations. The sky doesn't just heat, it reorganizes. Chemically, an AGN turns the atmosphere into a tunable reactor. With ozone thinned, short wavelength UV penetrates deeper, shifting the altitude of peak photolysis for CO, CH, and NH, rewriting vertical mixing ratios and the infrared opacity budget. Soft X-rays generate deep ion pairs, enhancing ion molecule routes that favor nitriles and isonitriles. HCN appears alongside CN, CH, and HCO, and formamide can rise from CONH. UVX synergy on aerosols or mineral surfaces warmed by transient heating. PAHs that would otherwise survive get cracked into reactive fragments. Those same fragments polymerize into tholin-like hazes when the flux ebbs, muting the star with an amber veil. If the planet carries oceans, photochemical nitrate rainout spikes after AGN flares, delivering fixed nitrogen to the surface while peroxides and formaldehyde accumulate in shallow layers, a feedstock for reductive amination and sugar formation under the right mineral templating. Too much flux sterilizes, the right duty cycle months to years burst separated by quiet centuries acts like a cosmic lab protocol: irradiate, quench, concentrate, repeat. The geometry matters. AGN illumination is not a uniform bath, it is anisotropic, filtered by a dusty torus, collimated by polar outflows, chopped by clouds in the circumnuclear ring. A planet's exposure swings with galactic latitude, orbital precession around its star, and the clumpy ISM between. Hundreds of parsecs off-plane might mean a gentle UV enhancement that tickles photolysis without erasing ozone. Tens of parsecs down a polar channel can mean impulsive soft X spikes that drive atmospheric escape, boost exospheric temperatures, and push H and He beyond the gene's limit. Magnetospheres help but do not absolve. Ion precipitation patterns redraw auroral ovals, catalytic NOx production migrates with field geometry, and lower latitude chemistry lights up when ring current particles dump energy at mid-altitudes. Even clouds respond. Increased ionization changes cloud condensation nuclei and droplet microphysics, subtly feeding back on albedo while the shortwave spectrum itself is being rewritten. Biosignatures and technosignatures get complicated under this AGN solarium. The classic OO pair can be suppressed without life changing at all, while NO, HNO, and HCN become time-variable tracers of high-energy forcing rather than metabolism. Methane lifetimes shrink, CO rises, disequilibrium increases for reasons that mimic biology to a casual glance. Spectra acquire sharp edges and transient shoulders. Rayleigh slopes steepen when small hazes dominate. Collision-induced absorption bands of NN and OO shift with pressure as escape whittles the atmosphere. Surface UV indices become episodic, selecting for subsurface or subaqueous niches. Photolysed thiols and metal sulfur clusters on mineral interfaces act as light-harvesting proto-catalysts, while clays and basalts irradiated by X-rays store radicals that later drive dark reactions. The same rays that erase can also write. None of this happens in isolation. Galactic ecology: star formation rings feeding gas to the nucleus, supernova-driven turbulence lifting dust above the plane, molecular clouds drifting across sightlines modulates the dose. Duty cycle, column density, and spectral hardness are the knobs. Shift hardness toward softer X-rays and you maximize ion chemistry per unit heating. harden the spectrum and you drill deeper, risking escape but also enabling subsurface photochemistry via luminescent minerals. Introduce intermittent shielding torus clumps, ISM filaments, and you create a strobing regime where radicals accumulate during bursts and couple during lulls, a natural pump for prebiotic complexity akin to wet-dry cycles on young terrestrial shores. In that regime, nitriles, aldehydes, and simple sugars can coexist with oxidants long enough to encounter metal sites, form imines, and step toward amino acids and nucleobases before the next blue noon arrives. So when the core brightens and the planet slips into half-shadow, the sky takes on a spectral glow, airglow lines sharpen, auroral curtains drift equatorward, and the upper atmosphere hums with reactions that textbooks reserve for laboratories. Sometimes the AGN scours. Sometimes it seeds. The difference lives in geometry, timing, haze, and the stubbornness of chemistry to exploit any gradient it is given. Turn up the flux a little more and the atmosphere starts keeping score. Ion pair production climbs quasi-linearly with soft X-ray brightness, and below about a few hundred nanobars the chemistry bifurcates. One branch runs oxidizing hot, amplifying NOx and HOX and collapsing O, the other runs carbon crafty, where dissociated CO and CH stitch back together into nitriles, aldehydes, and unsaturated chains faster than UV can erase them. The pivot is altitude and water. Dry, high atmospheres lock into NOx-catalyzed ozone loss with deep UV penetration. Moist ones flood the middle air with OH and HO that first shred methane but then funnel carbon into HCHO and CHO pathways that are perfect feedstock once photons relent. In that on-off cadence, radicals become memory. Reservoirs like HNO₃ and peroxynitric acid store oxidizing potential during bright phases and leak it back in the dark, while surface films, iron oxides, clays, phosphates hold photogenerated charges that bias the next reaction step long after the sky dims. Habitability under an AGN is not a binary but a map with sharp coastlines. Surface UVC doses surge during bright windows, but water columns and rock overhangs attenuate by orders of magnitude within centimeters. A river mouth rich in suspended organics becomes a photochemical diode, letting blue photons write reactive carbon on the skin of my cells and protecting fragile bonds a few millimeters below. Microbes with photolyases tuned to the shifted spectrum would own the shallows, those without retreat to mats shaded by Tholin haze where scattering favors redder light and ROS production is manageable. Evolutionary pressure points flip compared to quiet galaxies, antioxidant networks, nucleotide excision repair, and error-prone polymerases stop being luxuries and become gates to persistence. Metal-sulfur clusters and flavins double as UVX transducers, turning damage into gradients and gradients into metabolism. Even if life has not yet sparked, surface-subsurface shuttles powered by episodic irradiation can ratchet complexity HCN oligomer films that cross-link to melamine-like networks, formamide pools driven along dehydration-rehydration loops on warm basalts, sugar-amine condensation stabilized on borate-bearing margins before the next pulse. The detection game changes accordingly. Transmission spectra taken during a quiescent AGN month can lie. The same world under a flare shows NO at M brightening, NO near. M deepening, HNO features around M sharpening, while OO and ON collision-induced shoulders. And M wobble with pressure as escape breathes the air column. Night glow at M from OAG and the OH-minal bands paints the limb during the recovery phase. Lyman alpha and He2A variability telegraph the irradiance history passing through the dusty torus baffles. Phase curves pick up auroral heating as a moving hot spot. Polarimetric swings betray fresh haze formation after carbon chain cracking events. Stack all that with radio aurorae modulated by magnetospheric precipitation and you can reconstruct a duty cycle, how often the cosmic tanning bed lights up, how hard, and for how long. Laboratories and models are catching up. X-ray beamlines and VUV lamps aimed at realistic gas mixes show that even modest soft X doses drive ion molecule ladders that neutral photochemistry never reaches, favoring HCN amide routes and accelerating nitrate production by factors that matter for ocean biogeochemistry. Plasma chambers seeded with CO and HO under trace CH generate nitrile-rich aerosols whose IR fingerprints match what telescopes could plausibly see. Mineral-coated substrates record prebiotic steps when irradiation is pulsed rather than continuous, with yields peaking at intermediate repetition rates. Too slow and radicals diffuse or recombine unproductively. Too fast and fragile intermediates never meet. Coupled climate chemistry codes add the last essential loop. Clouds respond to ionization, alter shortwave fields, change surface UV by tens of %, and in turn reshape the very chemistry that seeded the droplets. Geometry keeps being the quiet tyrant. A world peeking through a polar funnel of the AGN sees hard light and deep ionization, scoot a few tens of parsecs behind a clump in the circumnuclear ring and the spectrum softens, dosing the mesosphere rather than the thermosphere. Dust columns repaint the color of day. Scattered blue from the core makes twilight eternal on one side of the sky while the host star still rules the other. In that half-lit regime your visual becomes literal, a planet in penumbra with a spectral halo, emerald OH arcs, ruby OINM whispers, ultraviolet curtains crawling toward mid-latitudes as magnetospheric footprints widen, rays knifing through a high haze whose gradient is not a Photoshop trick but a radiative transfer consequence. What this means for search strategies is simple and radical. Stop asking is there ozone, and start asking what is the timeline. Time-resolved spectra, flare phase monitoring, cross-correlating auroral lines with mid-IR nitrates and nitriles, catching the rebound of CH lifetime and the relaxation of NO, biosignatures become stories told across weeks to years, not single snapshots. Worlds under an AGN are laboratories with cosmic scheduling, irradiate to diversify chemistry, quench to assemble, shield to preserve, and repeat until complexity learns to copy itself. Sometimes the sequence sterilizes. Sometimes it scripts the first paragraph of biology. The difference is a handful of knobs: hardness, flux, water, haze, field, and the relentless opportunism of chemistry to turn catastrophe into a catalyst. Push closer to the core and the physics start speaking in numbers. Each EV of deposited soft X energy makes an ion pair, so a transient dose of EV-CMS through the thermosphere means cascades of ion pairs CMS, a rain of secondaries that prise open reaction channels no quiet photosphere can reach. Nitrogen splits into ND and NS, oxygen into OD, and the atmosphere pivots onto fast catalytic loops, NOONOO, NOOONOO, with Hawk cycling in parallel so quickly that ozone layer becomes a dynamic variable, not a shield. When the beam eases, recombination and rainout don't simply reset, they write history into reservoirs, HNO in the mid-air, nitrates in shallow seas, peroxides lodged in droplets, that prime the next bright phase with stored oxidizing power. Carbon chemistry rides these tides. Crack CO and CH at altitude and you flood the column with CO, H, CH, and O, couple those with ion molecule ladders and nitriles bloom, CN, HCN, HCN, and isonitriles that are awkward to make thermally but straightforward when ions hurt collisions. Formamide emerges where CO, NH, and surface charge meet. Aldehydes and sugars sprout via formose-like steps once borate or mineral facets hold fragile intermediates long enough to be copied forward. Too much flux hardens the atmosphere, drives escape, and sands chemistry down to CO and N. The sweet spot is a pulsed regime, minutes to days of hard light, weeks to decades of quench, where radicals accumulate, then meet, then get archived in films, clays, and brines before the next blue noon. The environment is not uniform even on one world. Along magnetic field lines, precipitation paints auroral ovals with NOx factories. At mid-latitudes, secondary electrons thicken OH and HO, shifting methane lifetimes by orders of magnitude between flare and calm. In coastal shallows, centimeters of water cut UVC by factors of 1,000,000. At the air-sea interface, peroxide and formaldehyde spike within minutes of a pulse, feeding reductive amination on iron-rich grains that warm just enough under X-ray absorption to drive dehydration without cooking products. Rivers heavy with organics act like photochemical diodes, absorbing hard light in an amber skin while sheltering nascent polymers millimeters below. Haze is a thermostat and a librarian, Tholin-like aerosols spawned by cracked PAHs dim the next pulse, redden the spectrum, and store radicals in conjugated networks that later leak reactivity into dark chemistry. Observation turns into timekeeping. A single transmission spectrum lies, a sequence tells the truth. During bright phases, NO at M flares while NO near M and HNO around M deepen, OAG nightglow at M sings in recovery, and OH minal bands lace the limb as Hawk's cascades cool. Collision-induced shoulders of OO and NN breathe with pressure as escape shaves the exosphere, mid-IR windows pick up nitriles waxing when CH lifetimes crash. Polarimetric swings betray fresh haze, and thermal phase curves show a marching hot spot where auroral heating drifts with the magnetosphere. Layer on stellar lines that proxy AGN throughput, lie alpha and HNO₃ variability diffracted by the dusty torus, and you can reconstruct a duty cycle, not just whether a world is being tanned, but how often and how hard. Laboratory analogs are converging on the same plot. VUV soft X beamlines aimed at CO and HO with trace CH reproduce the ion ladders that pile up HCN and formamide at rates neutral photolysis misses. Plasma chambers puffed with nitrate-rich aerosols yield IR fingerprints that match what telescopes could actually see through a hazy limb. Pulse the sources instead of leaving them on, and yields peak at intermediate repetition, diffuse too long and radicals die alone, hammer too fast and intermediates never meet. Add wet-dry emulation on basalts and clays, and you watch CN scaffolds crosslink into UV-tough films that become better at harvesting the next pulse, a primitive form of environmental learning in chemistry long before metabolism shows up. Zoom out to galactic context and the knobs multiply. A world peeking down the AGN's polar funnel gets hard spectra that drill to the thermosphere, slide behind a clump in the circumnuclear ring and the bathe softens, lighting the mesosphere and sparing the exobase. Supernova-driven fountains loft dust that blues the day, star-forming rings feed the core and set the beat of flares, drifting molecular filaments strobe the beam so that chemistry runs in bursts. Geometry is destiny, column densities, viewing angles, and magnetospheres decide whether the same photon field sterilizes desert surfaces or seeds subsurface lakes, whether mid-air nitrates wash into oceans as fertilizer or hang aloft as IR active veils that calm the surface by day and warm it by night. Life, if it exists, adapts to the metronome. Photolyases retune to shifted UV, antioxidant circuits become architecture, not accessory. Error-prone polymerases trade fidelity for survival when the sky goes hard blue. If life does not yet exist, the atmosphere-ocean mineral stack still behaves like a reactor with memory, radicals stored, nitrates banked, peroxides cached, surfaces charged, all waiting for the quench that lets fragile bonds knit. The AGN solarium is not simply hostile or kind, it is a schedule. Irradiate to diversify, quench to assemble, shield to preserve, repeat until complexity learns to copy itself. In that half-lit visual, core blazing like a second sun, a planet in penumbra, spectral halos flickering in the upper air, the chemistry of a sky inches toward biography, dial the picture into numbers and it gets even more gripping. A typical Seyfert-like core with XUV luminosity bathes its neighborhood with a flux that falls as LR, at PC, that's erg CMS, at KPC, erg CMS, at KPC, erg CMS. Your host star still rules the bolometric day, but the nucleus owns the chemistry, because these photons are hard and sparse surgical rather than warm. Cross-sections tilt the battlefield, photo E lets soft X-rays carve the thermosphere while EUV hammers the mesosphere, a dusty torus with an H filters the spectrum into windows that move the altitude of peak ionization by tens of kilometers. The difference between sterilization and stimulation is a few factors in hardness and a few parsecs in geometry. Atmospheric loss responds in kind. Under elevated XUV, energy-limited escape scales roughly as MRPF sub GMPK, so a super-Earth with a puffy HE vest can shed mass episodically during bright phases, while a water-rich secondary atmosphere clings and reshapes instead of vanishing. ON chemistry outruns climate on short timescales, NO₃ and NO₃ cycles can erase hundreds of Dobson units of ozone in days if ion pair production spikes. Recovery depends on rainout of HNO and the slow rebuilding of O via OOMO under a sky that hasn't quite calmed. HNO₃ adds a second break. HO photolysis seeds OHHO that both shred CH and, paradoxically, feed formaldehyde and peroxide reservoirs that become reagents once the beam dims. The net result is a living column. Oxidants and nitriles pulse with the duty cycle, not with the seasons. Carbon-nitrogen coupling rides those pulses. Crack CO and CH high, shower the mid-air with secondaries, and ion molecule ladders push CN-HCN-HCN while neutral channels spin up HCHO, CHOH, and small aldehydes. Where NH is present even at trace ppm, formamide appears at mineral or aerosol interfaces that hold charge. Wet-dry excursions on basalts or clays favor reductive amination and sugar formation, especially if borate or phosphate pins label intermediates. Too much dose and you planarize to CON haze. The sweet spot is pulsed, minutes to days bursts, weeks to years quench, letting radicals accumulate, meet, and archive into films before the next spectral noon. Magnetospheres and air sea skins make microclimates of survival. Auroral ovals become NOx factories that march equator-ward during peaks. Mid-latitudes thicken in OHHO, modulating CH lifetimes by orders of magnitude between flare and calm. Centimeters of water attenuate UVC by factors of 1,000,000. The top millimeter becomes a photochemical diode where peroxides and carbonyls spike within minutes, then drift into the dim layer below to be stitched into amines and sugars on iron-rich grains warmed a few Kelvin by X-ray absorption. Haze does double duty as thermostat and librarian. Tholin-like aerosols born from cracked PAHs mute the next pulse and store radicals in conjugated networks that leak reactivity in the dark, turning catastrophe into a catalyst. Detection stops being a snapshot and becomes a schedule. During bright windows, NO at M and NO near M flare while HNO at M deepens. OAG nightglow at M and OH minal bands lace the limb in recovery. OO and NN collision-induced shoulders at M breathe with pressure as escape schemes the exosphere. Nitriles bloom in the NM regions when CH lifetimes crash. Polarimetric swings reveal newborn haze. Thermal phase curves show a marching hot spot from auroral heating. Cross-correlate those with variability in Li alpha and He2A leaking through torus gaps and you can reconstruct the duty cycle: how often, how hard, how long the solarium lights run. Laboratory and chamber work mirrors the sky. VUV soft X beamlines on CO and HO mixtures with trace CH reproduce ion ladders that neutral photolysis can't reach, accelerating HCN, formamide, and nitrate production to geochemically meaningful rates. Pulse the radiation and yields peak at intermediate repetition. Wait too long and radicals die alone. Hammer too fast and intermediates never meet. Add mineral templates Fe-Ni sulfides, TO, montmorillonite, and you watch CN scaffolds crosslink into UV tough films that get better at harvesting the next pulse, a primitive, physical learning long before enzymes. Galactic context keeps its hand on the dimmer. A planet peering down an AGN's polar funnel sees hard spectra that drill to the thermosphere and torque escape, slide behind a circumnuclear clump and the bath softens, lighting the mesosphere and sparing the exobase. Supernova fountains loft dust that blue tilts the scattered day, star-forming rings throttle the core and set the beat, drifting molecular filaments strobe the beam so chemistry runs in bursts. On the world itself, coastlines, clouds, and field lines carve mosaics where sterilizing noon 100 kilometers up becomes prebiotic twilight a centimeter below water, and where oxidant rainout writes nitrate into deltas like a cosmic fertilizer schedule. Life, if present, is forced into agility, photolyases tuned to a shifted UV palette, ferredoxin and flavin networks that double as damage sensors and energy harvesters, polymerases trading fidelity for survival under hard blue skies. If life hasn't begun, the stack of atmosphere-ocean minerals still acts like a reactor with memory radicals banked, nitrates cached, surfaces charged waiting for the quench that lets fragile bonds knit. That is the lure of the AGN solarium, not merely a hazard, but a metronome. Irradiate to diversify, quench to assemble, shield to preserve, repeat until the chemistry of a sky crosses the narrow gap into biography, while above it all the core burns like a second sun and the limb of a planet glows with spectral halos that tell, line by line, what the heavens have been doing to its air. Slide the nucleus from Seyfert calm to Quasar loud and new levers appear. Halogens wake up, Cl and Br liberated from sea salt and mineral aerosols under hard UVX become catalytic chainsaws, ClO, ClO, gnawing ozone in tandem with NOx and HOx while also attacking CH through fast abstraction, shortening methane's lifetime from years to days during peaks. Sulfur flips polarity with altitude, so photolysis and ion routes build H so that nucleates fine aerosols, cooling the surface by day and trapping IR by night. In drier, higher layers, CS and OCS become resilient carbon-sulfur shuttles that seed thioesters on mineral faces when pulses warm the skin just a few Kelvin. Isotopes keep a ledger of all this. Escape scours light H and He first, enriching DH in the exosphere, fractionating reactions imprint N into nitrates during bursts and shuffle C between CO and organics as haze forms and cracks, signatures that, given time resolve spectra, separate AGN weather from biology. Chemistry couples back to climate in irregular beats. As though Lin-like haze thickens, shortwave scattering reddens the ground light, pushing phototrophs real or proto toward pigments that drink longer wavelengths. Ion-induced nucleation livens cloud decks, droplet microphysics shifts under enhanced charge, altering albedo by tens of % on weekly timescales, enough to swing surface UV by similar factors even if the incident flux holds steady. The ocean is an integrator, nitrate and peroxide rain out after bright phases goose primary productivity where life exists, or concentrate redox currency where it doesn't. Ferrous shorelines host Fenton-like cycles that turn stored peroxides into hydroxyl bursts, a chemical heartbeat that syncs with the core. Subglacial lakes and porous basalts become refugia and reactors, their porosity setting a residence time for radicals and small molecules long enough to let chance meetings become pathways. Detection strategies can exploit the cadence rather than fight it. Program telescopes to watch in AGN seasons, stack emission and transmission spectra across flare, plateau, and recovery, cross-correlate mid-IR nitrates and nitriles with near-IR nightglow and far UV proxies of the core, add polarimetry to catch fresh haze and radio to time auroral precipitation. Extremely large telescopes resolve limb brightening in OAG at M as the atmosphere relaxes. Space observatories watch NO at M and HNO near M wax and wane. UV monitors track the core's Li alpha He2A trickle through torus gaps. A world that repeats the same chemical arc after each pulse, ozone crash, NOx spike, nitrile bloom, haze thicken, oxidant rainout, CH recovery, advertises an external metronome. A world that damps those swings with biology's buffers, stable mixed layer redox, fast carbon drawdown after flares, pigments that migrate to the spectrum the haze leaves behind, whispers adaptation. None of this demands miracles, only gradients and time. Hard photons write radicals into air and water, minerals hold charges and template bonds, pulsed forcing prevents both stasis and total erasure. Between sterilizing glare and quiescent drift lies a narrow band where catastrophe doubles as catalyst. In that band, a planet half lit by a galactic core grows a spectral crown, emerald OH, ruby OI, ultraviolet curtains, and a chemistry that learns its rhythm, nudged step by step from atmospheric physics toward autobiography, tip the spectrum further into the soft X regime and the mesosphere becomes an electrical machine. Secondary electrons with mean energies of a few tens of eV avalanche through N, producing excited NBC that radiate the Vegard-Kaplan and second positive systems while metastable OD and OS pump the familiar NM and NM lines. That glow is not decoration, it is a budget. Photon yields map directly onto ion pair production, and ion pair production maps onto catalytic capacity. Every EV buys one ion pair, every ion pair buys a handful of NOx-HOx turnovers before reservoirs trap them as HNO or HO. In the lower thermosphere, electron temperatures rise hundreds of Kelvin above neutral gas during peaks, broadening ambipolar diffusion and lifting light species. In that window H and He leak while heavier molecules ride gravity waves downward, seeding mid-air chemistry that would otherwise be starved. Prebiotic ladders climb fastest in places where solids and pulses meet. On basaltic beaches, Fe2 Fe3 minerals catalyze reductive amination the moment formaldehyde and ammonia arrive from the air-sea skin. Phosphate-bearing ash beds stabilize glycolaldehyde and glyceraldehyde against Cannizzaro-Back reactions. Borate pin cis diols long enough for aldol steps to outrun hydrolysis. Time the AGN with tides and the shoreline becomes a cycle counter. Bright phase peroxide and carbonyl spike, depth concentration, quench condensation and imine formation. Next bright phase selective photolysis that prunes side products and anneals chromophores into UV tough films. Those films darken, stacks and conjugated nitrile networks and, paradoxically, harvest the next pulse more efficiently, converting a destructive spectrum into surface work. Halogen and sulfur microcycles add sharp edges to that choreography. Sea salt aerosols photolyze to Cl and Bro chains that shred O and Ch yet also drive fast carbonyl halide exchanges, opening acyl activation routes that mimic thioester chemistry on mineral faces. Ion-induced nucleation of H. So with organics births ultrafine haze at rates that jump by orders of magnitude during peaks. Coagulation then shifts the size distribution into the Mies sweet spot, steepening Rayleigh slopes and muting blue light at the ground just as biological pigments would prefer to slide redward. If biology is present, you expect photolyases with broadened action spectra, ROS-hardy carotenoids, and flavoproteins that double as redox sponges. If it isn't, the same molecular motifs emerge anyway because conjugation and radical delocalization are the cheapest ways for matter to survive a hard sky. Observationally, the lure is temporal structure hiding in plain lines. NO at M flares within hours, NO near M lags by chemistry, HNO at M integrates the weak, OAG nightglow at M peaks in recovery while OH- bands trace the hawk's tail, nitriles in the NM windows crest as CH lifetime collapses, OO and NN collision-induced features at M breathe with pressure as escape shaves the exobase. Polarimetry catches newborn haze, radio watches cyclotron aurorae set by magnetospheric precipitation, UV monitors track Li alpha and He2A trickling through torus gaps that act like a rotating shutter. Stitch those channels and a duty cycle falls out, flare ozone crash knock spike nitrile bloom haze thicken oxidant rainout partial recovery. If a world damps that sawtooth, drawing carbon down faster than physics alone allows and stabilizing mixed layer redox after each hit, you found adaptation. Push the visual and at ISNT fantasy, a planet in penumbra under a quasar blue sky, limb etched in emerald OH arcs and ruby OI whispers, the dayside carrying a faint steel sheen from ion-nucleated haze while the terminator glows with M night air. Rays from the nucleus rake the high clouds as a realistic gradient runs from violet scattering overhead to warm amber near the horizon, and in that graded light the upper atmosphere writes and erases chemistry at clock speed. Sometimes the solarium sterilizes. Sometimes it scripts a method, irradiate to diversify, quench to assemble, shield to preserve, repeat until the ledger of reaction stops reading like physics and starts sounding like a biography, turn the dial to particles and the plot thickens. AGN jets and winds don't just ship photons, they inject cosmic rays with MeV-GeV energies that slip through dust baffles and light up chemistry where UV can't. Ionization rates climb from S Milky Way quiet to S in exposed columns, and that 3-order boost rewires lower atmospheres. HHH becomes a universal acid for proton transfer ladders, N cracks via helium charge exchange, deep Knox Hawkes production proceeds without direct UV, so ozone can collapse even under a hazy, reddened day. Secondary electrons thermalize slowly in dense air, extending radical lifetimes. Add trace metals and you get phantom-like bursts where HNO₃ turns stored oxidants into sharp chemical spikes, microsecond lightning in a beaker the size of a planet. Dose response has thresholds. Below an integrated XUV dose of Jm per event, you perturb but recover, O minima rebound within weeks as HNO rains out. Between and Jm, CH lifetimes crater, nitriles bloom, and haze flips climate short-term. Beyond Jm you start energy-limited escape for He and heat the exobase enough that O starts to leak unless gravity or cooling COM, NOM keeps pace. Chemistry loves the middle band, enough radicals to diversify, not enough to plane everything down to CO and N. Surfaces answer in kind. Silicates doped with Fe Ni and sulfides machanoite graphite accumulate photoholes and electrons under hard light, with NH and HCHO around. Imines form, reduce, and rearrange into aminocarbonyls. Formamide pathways accelerate on TO and phosphate-bearing clays, amide bonds, urea, and nucleobase precursors arise measurably faster when irradiation is pulsed seconds hours than when it's steady, because selective photolysis prunes dead ends. Even perchlorates easy to make in oxidizing air can be helpers, storing oxidant that later bleaches side products while leaving robust conjugated scaffolds intact. This is observable with today's and near-future glass. JWST spec catches time variable NO and the HNO₃ nitrile shoulder during recovery. MIRI sees HNO at M and the M-nitrile plateau crest during peaks. High dispersion cross-correlation on ground ELTs can chase NO at M and CN/HCN in M windows against telluric noise if you watch through an AGN season rather than a single transit. Add polarimetry for newborn haze and low-frequency radio for cyclotron aurorae, and you can solve the duty cycle and spectral hardness leaking through the torus. Zoom back to the scene you'll show, core blazing like a cold blue sun, a planet half-turned, dayside with a faint steel sheen from ion-nucleated haze, the limb etched by emerald OH arcs and ruby OI whispers, a realistic gradient from violet overhead to amber near the horizon. Under that gradient, the sky runs a program, irradiate, diversify, quench, assemble, until physics edges into autobiography, now fold in where such worlds actually live. Closer to galactic centers, stars skew older and metal richer, so disks start with higher dust to gas and migrate faster. Compact chains of sub-Neptunes and super-Earths are common, the very architectures whose atmospheres are most vulnerable to hard light. Around M dwarfs already UV noisy, and AGN overlay turns intermittent stress into climate. Baseline flares from the host star set the floor, nucleus pulses set the ceiling, and the chemistry in between never quite equilibrates. Redder photospheres help ground UV a bit, but soft X-rays and cosmic rays ignore color and go to work deep, collapsing ozone even when haze has muted the blue. In metal-rich systems the payoffs are double-edged, more volatiles and seeds for clouds, more PAHs to crack into reactive fragments that later polymerize into protective tholins, thermostat and sunscreen grown from the sky itself. Timescales decide fate. Torus clumps orbit on years to decades, letting the nucleus strobe a sector of the disk, star-forming rings beat on year cycles, jet knots cross sightlines on months. If the atmospheric chemical half lives hours, weeks for NOx-HOx, months for CH under hard fields, years for haze turnover commensurate with these beats, you get resonance. Radicals produced at each pulse meet surviving intermediates from the last one, yields climb superlinearly, and prebiotic seasons emerge with dry or warm-cool analogs driven by the core rather than the weather. Detune the cadence and the same dose spreads thin, letting repair outpace damage, life if present buffer the column, and the spectral sawtooth round off into a hum. Retrieval under this sky is a choreography problem, not just a signal-to-noise one. Snapshot spectra confound, O false negatives during NOx spikes, CH false negatives in bright windows, CO false positives that look geochemical but are merely photolytic. The cure is phase and cadence, stack transits and eclipses by AGN state, tag each with contemporaneous proxies of the core He2A leakage, X-ray monitors, and invert differences rather than absolutes. Look for chemically synchronized pairs, NO rise with O fall, HNO growth with OAG nitrile rebound, nitrile bloom with CH lifetime crash. Cross-correlate polarimetric slope changes with mid-IR haze features to catch fresh aerosol growth, and use radio aurorae as a clock for magnetospheric precipitation that seeds low-latitude NOx factories. Biosignatures in this regime become response functions, fast carbon drawdown after flares, stabilized mixed layer redox, pigments drifting toward wavelengths the haze leaves open. Shielding is not binary. A parsec-scale molecular filament cuts hard EUV by orders of magnitude yet leaks soft X-rays and MeV particles, a high-latitude sightline through the polar funnel flips that balance. Even planetary weather participates. Deep convective towers lift NOx to altitudes where catalytic loops run hotter, stratiform decks trap HNO until rainout fertilizes river deltas like a cosmic clock. Ocean optics matter. Colored dissolved organic matter turns the upper centimeter into an amber diode, harvesting the pulse for chemistry while protecting below. Sea spray feeds halogen chains that both prune ozone and activate carbonyl chemistry at the droplet skin. On land, ash beds rich in phosphate and borate behave like chemical RAM, caching intermediates between pulses. Basalt glass and Fe-S grains act like Schottky junctions for charge-separated steps. Numbers keep the picture honest. Let rise to S and H columns climb to Cm, enough to protonate CO and N into reactive ladders in air too dense for UV. Let Fx UV swing from to erg CMS over an AGN season, and energy-limited escape bleeds He on sub-Mir timescales for puffy sub-Neptunes while secondary CO and atmospheres on rocky worlds ride out the pulses with composition swinging but mass mostly intact. Ozone can drop by hundreds of DU in days when ion pair production spikes to CMS. Recovery takes weeks if rainout is efficient, months if the column is dry and cold. Haze optical depths of in the visible are enough to tilt ground spectra redward by tens of %, right where pigments or proto-pigments would evolve to drink. Hold the visual and it still reads true, the core as a cold blue lantern, the planet rotated into penumbra, a steel fine sheen of ion nucleated haze on the day side, at the limb, emerald OH arcs and ruby OI whispering through a realistic gradient from violet to amber. In that light the sky runs its loop, irradiate to diversify, quench to assemble, shield to preserve, until chemistry ceases to be a weather report and starts to sound like a diary. Sometimes the solarium erases. Sometimes it rehearses life until the lines stick, turn to composition and the response sharpens. NO skies run NOx-dominated loops, CO heavy skies add efficient IR cooling M that caps exobase temperatures and slows escape even under the same XUV, while H-rich envelopes amplify ion molecule chains. H becomes the universal proton donor, funneling carbon into CHOH and nitrogen into NH-amides with rates neutral chemistry never touches. Trace CO tips the deck toward formaldehyde and formose-like networks. Trace so seeds H so nucleation that snaps the climate response from brightening thin haze to dimming optically thick Mia scatterers once effective radii cross a few tenths of a micron. Halogens act as accelerants nearly everywhere. ppb level CLB are liberated at the droplet skin collapse O and abstract H from CH at rates that shorten lifetimes by orders of magnitude during peaks, then park as HCl-HBr until the next pulse. Radiation transport writes the altitude of action. Compton down scattering softens X-rays as they descend, moving ionization peaks downward by kilometers and extending the chemistry shelf into layers dense enough for three-body stabilization. Cosmic ray attenuation lengths of GCM let MeV GeV particles light up regions UV can't reach, combine both and you get two reaction engines, one fast and high, one slow and deep that couple through vertical mixing and gravity waves. Magnetospheres modulate the map but don't decide it alone. Strong dipoles shunt precipitating particles to ovals that march equatorward during maxima, while multipolar or weak fields smear deposition and spread NOx factories into mid-latitudes. Add rings and moons and you get shadow stencils. Ring shadows cool columns and slow photolysis locally. Volcanically active moons inject so-na Cl that alter halogen sulfur budgets planet-wide on seasonal timescales. Models that can follow this need to be hybrid. Couple ADGCM with an ion-neutral network reactions, self-consistent XUV soft X radiative transfer, and a kinetic upper atmosphere module that toggles between genes and energy-limited escape, feed it an externally forced light curve, a stochastic AGN process with torus occultations, jet knots, and ISM clumps, and let the column learn. When you allow aerosols to evolve microphysically, nucleation, condensation, coagulation, sedimentation under ionization, you see regime changes. At fixed dose, yield of nitriles and amides doubles when pulses align with the aerosol growth window, and flip sign when coagulation outruns condensation and scavenges radicals before they meet. Pulse repetition rates around the radical recombination time maximize prebiotic products, shift an order of magnitude faster or slower, and yields crash even if the integrated energy stays the same. Retrieval becomes differential spectroscopy plus clocks. In transmission, different spectra between bright and quiescent epochs isolate response lines NOM, HNO₃, Nitriles M, while OAG Niclo at M and OH- bands trace recovery. High dispersion dayside emission cross-correlation can lock onto NOM and CN₃ as they flare. Polarimetry tracks fresh haze through slope changes and rainbow angles, low-frequency radio times cyclotron aurorae that mark precipitation and, by extension, deep NOx production. Tie all of it to simultaneous AGN proxies HNO₃ leakage, soft X monitors, and invert trajectories, ozone crash, NOx spike, nitrile bloom, haze thickening, oxidant rainout, CH recovery rather than single abundances. Biosignatures translate into response functions: rapid post-flare carbon drawdown, buffered redox in the mixed layer, pigment bands drifting toward the spectral windows the haze leaves open. The lab roadmap mirrors this cadence. Beamline campaigns with pulsed VUV soft X on CO and HO-CH-NH mixes quantify ion pair yields, and branching to HCN formamide, flow tube ion chemistry nails H-mediated ladders in H-rich gas, microfluidic wet dry chips on Fe-S, TO, and phosphate clays clock imine formation, reductive amination, and sugar stabilization under on-off irradiation. Aerosol chambers under controlled ionization follow nucleation and coagulation to the MIA regime that telescopes actually see. Everywhere the same lesson repeats: pulsed forcing outperforms steady forcing for building complexity, because it both creates diversity bright and permits assembly and error correction quench. Hold the scene and it's still physically honest: a cork casting a cold blue lantern across the disk, a planet rotated into penumbra with a steel-fine sheen from ion-nucleated haze, limb etched in emerald OH arcs and ruby OI as the upper air relaxes, a realistic gradient from violet scattering overhead to amber along the horizon, spectral lines breathing with the duty cycle as the sky runs its program. Irradiate to diversify, quench to assemble, shield to preserve, until a column of gas begins. To keep a diary, anchor the narrative to a concrete case and the knobs get real. Our own galaxy's core has dozed for millennia, yet X-ray light echoes in SGR as neighborhood show century-scale flares at enough to tickle mesospheres a few kiloparsecs out if sightlines slip through dust. In starburst nuclei and Seyferts, the same luminosity jumps ride on duty cycles from months to decades as torus clumps orbit and jet knots drift. Translate those light curves into column chemistry and you get reproducible arcs, ion pair production peaking in the lower thermosphere, NOx factories marching equatorward with precipitation, Hawk's tails lengthening into recovery, nitriles cresting as CH lifetime collapses, haze optical depths walking from to and back. Stack a dozen such arcs and you watch a sky learn, reservoirs accumulate, surfaces darken, wet dry beats phase lock with bright quench forcing, and yields of amides and sugars hit plateaus that steady forcing never reaches. Habitability becomes a problem in shielding design, not blind luck. A magnetic moment a few times Earth's pushes NOx factories poleward and spares mid-latitudes, ocean color that leans into dissolved organics turns the top centimeter into an amber diode that harvests radicals and guards what lies beneath, continents with phosphate and borate-rich ash beds behave like chemical RAM, caching intermediates across pulses. Even ice helps. Porous firn shelters radicals and small molecules, then slow melts them into spring meltwater where concentration and quench are guaranteed. Under these conditions, the AGN solarium is less a coin toss and more a curriculum. Stress teaches repair, pulses teach assembly, haze teaches spectral budgeting. Observationally, the way in is orchestration. Tag each exoplanet spectrum with a state vector for its host nucleus contemporaneous HNO₃ leakage, soft X flux, and, if possible, a radio proxy for jet activity and invert differences rather than snapshots. Retrievals that allow time-dependent priors pull cleanly on NOM, HNO₃, CN₃, while Niclo at MOAG and the OH- ladder map recovery. High dispersion cross-correlation on ELTs locks onto transient NO at M, polarimetry nails newborn haze through slope changes and shifting rainbow angles, low-frequency radio times cyclotron aurorae that clock deep precipitation and by extension deep NOx chemistry. The signature you're after is not a molecule but a metronome, ozone crash NOx spike nitrile bloom haze thicken oxidant rainout CH recovery, phase lock to the core. Models and labs can meet you halfway. Hybrid GCM ion-neutral frameworks with microphysical aerosols reproduce regime flips when pulse cadence matches radical recombination and coagulation times, beamline campaigns with pulsed VUV soft X on CO and HO₃ measure ion pair yields, branching to HCN formamide, and nitrate rainout, microfluidic wet-dry chips on Fe-S, TO, and phosphate clays show imines and aminocarbonyls rising fastest under on-off schedules, with selective photolysis pruning dead ends during bright windows. Everywhere the same lesson, diversity under light, assembly in the dark, memory in reservoirs and films. Push the parameter space and edges appear. H-rich envelopes amplify H-ladders and drift toward CHOH-NH chemistry unless XUV crosses escape thresholds. CO thick skies cool their exabases with M emission and ride out similar doses with more composition swing than mass loss. Halogen wet worlds swing harder CLBr chains crash ozone and /CH lifetimes during peaks but park as HCl-HBr between pulses, setting a chemical pendulum that telescopes can time. Cosmic rays fill in the shadows, rising to S drives deep ion chemistry where UV can't, turning cloudy, hazy, or sunlit pour columns into active reactors anyway. Keep the visual tether to physics and it still holds, a core casting a cold blue lantern, a planet turned into penumbra, a dayside with a faint steel sheen from ion-nucleated haze, the limb etched by emerald OH arcs and ruby OI at an NM. A realistic gradient from violet overhead to warm amber along the horizon as aerosol size distribution walks through the Mies sweet spot. In that light the column runs its loop, irradiate to diversify, quench to assemble, shield to preserve, until spectra start keeping time like a diary. Sometimes the solarium erases. Sometimes it rehearses life until the lines stick. Bring it home with a test. Choose a compact, metal-rich system in a Seyfert host, monitor the nucleus with UV X-ray eyes for a year, schedule JWST MIRI and NIR spec time around predicted bright windows and recoveries, add ground HDC for NO and CN-HCN, polarimetry for haze, and low-frequency radio for auroral clocks. Invert trajectories, not single numbers. If the sawtooth appears and if post-flare carbon draws down faster than abiotic kinetics allow while mixed layer redox stays buffered you'll have caught a world using a galactic lighthouse as a chemistry engine. And if not, you will still have learned to read a sky by its cadence, which is the first step to finding biographies written in air. Treat the cadence like a signal processing problem and the atmosphere turns into a filter with memory. The impulse response is the chemistry triggered by a short burst. The transfer function is the set of catalytic loops and reservoirs that ring afterward. Convolve an AGN light curve with that response and you predict lines that should breathe on schedule, NO acting like a fast high pass, NO a mid-band integrator, HNO a low-pass storage term, OAGM nightglow a delayed echo of recombination. Retrieval becomes deconvolution, assume a stochastic driving flux built from torus occultations and jet knot crossings, regularize with priors on reaction timescales Knox hours days, Hawks minutes hours, Haze weeks years, and solve for the latent dose that best explains spectra across epochs. Hierarchical Bayesian fits let multiple planets in the same host share the same driver but different filters, one world H-rich with fast ion ladders, another CO thick with strong NO cooling, so you learn both the lamp and the laboratories. Geometry is an ally if you use it. Transmission spectra weight the terminator where ion chemistry and nightglow pile up, dayside emission emphasizes auroral heating footprints and fresh haze, reflected light polarimetry is hypersensitive to particle size, so newborn ultrafines from ion nucleation pop out as slope changes and rainbow angle shifts. Limb sounding with high dispersion cross-correlation can separate winds and altitudes. NO at M from the lower thermosphere will be broader and slightly blue or red shifted by MS jets, while nitriles formed lower ride gentler flows. Even simple phase binning helps. Compare spectra from AGN facing quadratures to those taken half an orbital period later and the metronome sharpens, because one hemisphere repeatedly sees the pulse first. False positives and negatives have patterns you can rule out. Volcano-dominated NOx lacks the tight anti-phase with O and the rapid M night glow rebound, lightning NO spikes without the contemporaneous hard spectrum proxies from the core. Abiotic CO rises under strong photolysis but won't pair with a synchronized nitrile plateau unless CH lifetimes crater at the same time. Conversely, biology can hide behind physics. O can look dead during NOx peaks, CH can look absent during bright windows. The cure is cadence. Stack differences by AGN state, require synchronized pairs NO₃, nitriles haze, and demand the expected lag structure minutes hours for HOX, hours days for NOx, days weeks for HNO haze. Numbers set feasibility. For a temperate super-Earth at PC, resolving NO of ppm in transmission across 2 or 3 bright windows is within JWST and IRspec prism stacks if you phase your visits with the nucleus and co-transits. MIRI LRS can chase HNO at ppm with comparable cadence. ELTs at R can cross-correlate NO at M at contrasts over hours spread across the flare and recovery, provided contemporaneous UVX monitors certify the driver. Polarimetric slopes changing by across M imply haze newborn haze, detectable with meter-class precision photopolarimeters if you watch the same orbital longitudes before and after a pulse. Escape and climate threshold separate scour from script. CO-rich skies with strong M cooling hold exobase temperatures below runaway for FXUV erg CMS, H-vests on sub-Neptunes bleed quickly once FXUV pushes energy-limited escape into the GS band, water columns by survival twice spectrally, by absorbing and scattering, and kinetically, by shuttling oxidants and carbonyls into brines where quench and concentration can finally cooperate. Halogen availability modulates volatility, ppb level CLBR turns peaks into deeper ozone troughs and shorter CH lifetimes, but those same chains park as HCl-HBr between pulses, making the next rise more dramatic and easier to time. Prebiotic bookkeeping favors pulses over plateaus. On Fe-S and TO surfaces, on-off irradiation prunes dead ends by selective photolysis while preserving conjugated backbones that become better light harvesters. Stacked nitrile films, melamine-like networks, quinone-style chromophores. In microfluidic wet-dry analogs, aldehyde-amine condensations and imine reductions climb when bright windows last minutes hours and dark assembly stretches days weeks, push the repetition an order of magnitude faster and intermediates never meet, slower and radicals die alone. Add halide and sulfate aerosols and the system starts caching capacity, peroxides and nitrates stored aloft and in the microlayer act like reagents waiting for the next quench, turning catastrophe into a catalyst. Evolution if it is underway learns the beat. Photolyases broaden action spectra toward the surviving ground light under haze, antioxidant networks bulk up, pigments drift redward to where scattering loses, repair pathways time switch with the sky. If life hasn't begun, the column still accumulates memory, nitrates in deltas, peroxides in the microlayer, radicals in conjugated films, charges on mineral facets. After enough cycles the ledger thickens until chemistry starts copying itself faster than it is erased. That is the narrow lane between sterilization and stasis, irradiate to diversify, quench to assemble, shield to preserve, repeat until the diary in the air reads like a first paragraph. Keep the shot in mind as you narrate it, the core as a cold blue lantern, the planet half turned into penumbra, a steel satin sheen from ion nucleated haze on the day, along the limb, emerald OH arcs and ruby OI at an NM, a realistic gradient from violet overhead to amber near the horizon. Lines breathe with the duty cycle, auroral hot spots march, haze thickens then rains out, nitriles crest where methane lifetimes crash. Sometimes the solarium erases. Sometimes it rehearses life until the lines stick, and if we watch by cadence instead of snapshots, we can tell which story the sky is trying to write.